நீ பேசிக்கோ ஹலோ சார்னு சொல்லி.
Good evening, sir. They're asking us to use a headset, Dad.
ஹெட்செட் சொன்னாரா?
Yes.
யார் சொன்னா? யார் சொன்னா?
See, it is saying use a headset with a built-in mic.
அவாய்டுன்னு தான் போட்டிருக்காரு. இட்ஸ் ஓகே.
இப்போ சும்மா ஒரே அடி போட்டு பார்த்தேன்.
ஏய் வைபவ், இது சும்மா கனெக்ட் பண்ண முடியாது வைபவ். இது அதுல இல்ல, இது
இது இன்னொருது.
மீட்டிங் நான் போணும்.
Give me another headset and go.
இப்போ வாண வைபவ் ப்ளீஸ் அப்ரோட் பண்ணு வைபவ்.
Dad, I've read.
ஒண்ணும் இதா போடுறது. இத்தனை நாள் அதே தான் பேசிருக்கேன். நீ சார் அப்பவே முன்ன கூட இந்த வீடியோல இப்படி தான் சொன்னாரு.
Good evening, sir.
சூடே கிடையாது, ரொம்ப ஆள் எடுத்து அப்படியே குடி. கடை 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 குடிச்சு விடு. இப்போ எல்லாம் சொட்டிட்டு போகிற பின்னாடி போய்ட்டு கொடுத்துரு என்கிட்ட நேரத்தும் பேச.
இல்லை இந்த சாப்பிட எடுத்துன்னு வரியா?
அதான் இருக்கேன்.
தெரியாது தவிர
வேறு என்ன இருக்கு எனக்கு எங்கிட்ட இல்லை.
வாட் இஸ் த டைம் நோ?
6:30 கரெக்டு.
I think everybody will start joining now.
நீ ஆரம்பிக்கலையா? நீ வந்து ஹவு டு கோடு கூட கேளு.
சரி சரி பேச. குட் ஈவினிங் சார். உங்ககிட்ட பேசல.
Hi, good evening. Good evening, everyone. Everyone has an Anya and Vaibhav. Where are the others?
Sir, maybe they might join late.
Yeah, we will get started, okay? We'll get started.
Yes, sir, no problem.
Okay, let's get started. Hey, Anya, Vaibhav, congratulations to both of you.
Thanks, sir.
Hey, Anya, did you participate last year also? Hello, Anya, are you there? Unmuted. Unmuted. Speak. Yeah, Anya, are you there in the class or are you just logged in and walked off somewhere?
No, here only, sir. I was kind of like.
Hey, no problem. What I was asking was whether you attended last year also, or this is the first time for the chip
Last
design?
year also, sir.
Oh, last year also. Excellent. So I have a teaching assistant today. Great. You can help me, okay?
Okay, sir.
All right.
Sir, I wanted to ask you. Last year we didn't get FPGA boards, and so did people who joined last year, like did they only get those FPGA boards, or how are we eligible to get the FPGA boards this year?
Last year also they got. Last year also the top 50 students got it. This time, they have been a little bit more liberal, so they have given it pretty much to everybody who attended. Okay. So last year it was very competitive. It was all India, and there were, I think, more than 700 students.
And this year?
Completed. This time I looked at the group. There are only about 600 students. Okay.
And how many have gotten those FPGA boards?
I think 500 of them.
Sir, and who like how many people have got selected? Like apart from us, how many people would have gotten selected for the second stage or second level?
Everyone who got the board is selected.
500 people.
Yeah.
So then almost everybody got selected.
Almost everyone. Yeah. So this
That
time
is
it
not
is.
really that good.
No, this time I think they have been a little bit.
Lenient.
I think they got sponsorship from Samsung or more number of boards, because each board retails at about 3,000 rupees. That is the price of the board. So Samsung is sponsoring it, so they must have said, okay, 500 boards is and they have restricted it only to Karnataka this time.
Why only to Karnataka?
Why is that, sir?
I don't know. Maybe they are doing state by state. I don't know. All right.
Kind of unfair.
I know. Last couple of years it has been all India. It was very nice. People from all over India, right? Anyway, let us get started. There is so much to cover.
Sir, there are only 2 students.
Doesn't matter. See, there are about 20 people who have confirmed. Okay, and I closed after that. about 20 people. Let's see, whenever they join, let them join.
Yeah.
Okay.
Sure,
So,
sir.
good. We can get started with specific questions that you might have, and then when the others join, we can do.
Oh, one more person has joined.
Yeah, Samarth has joined. All right. Let's get started. So, Anya, did you have? Of course, you have done this before. So,
Sir, my GitHub doesn't work. I open Riskly too, then it closes automatically and opens Riskly, and then it's getting all confusing in GitHub. I have to like wait a whole day for it to restart and all. And then I also have like my Olympiads and my exams are on Monday, so then it's very difficult for me to get around.
try from a different computer. See, GitHub, there won't be a problem. It's a platform. It's a global platform, so it will not glitch. It is not buggy. Alright, so it might be some configuration.
What the hell is wrong with you? Can you go
something
somewhere
like that.
else?
So try
The
to see everything from another computer and see. It will work. It's like saying
Baba
Google
Bimbu
is
Chino Archurappo.
if it will glitch for probably the whole country or something. So okay, it won't glitch for just one person.
Yeah.
So check, okay. Anything else you had in specific to ask for this class? Okay, Vaibhav, yes, go ahead.
Sir, so can you basically like explain the entire journey, like of the instruction, like when you send the code on that particular language like C plus like that to the hardware, like the RISC-V hardware in specific, and then its output comes out again to you. Like, can you explain the journey, entire journey, like from the start of the
Alright.
code till there?
Yeah, that's a good place to start. Okay. So the journey, I'll call it the journey. Okay.
ஒரு நோட் புக் ஒரு பென்னு கூட
பெண் இருக்கேன்.
Alright, so the journey is we use computers to do computation. That's what we use computers for. Ask it to solve problems, of course, play games, play movies, play videos. So some task we want the computers to do. That is us as users. We are users. Okay. Now, we users, we interact with a computer program. We interact with a computer program. And that program runs on the computer, so it executes code.
அது ஃப்ளூட் இது வேண்டாம் நீ பேசல நார்மல் வாய்ஸ்ல
CPU. And when you say computer program, it is binary code. Already it is binary coded. Computer program or app. So this is in binary, zeros and ones. Right. And this binary executes on the CPU or the processor, and then we get the output on the monitor or screen. Okay. This is the user workflow. So output. This is the user workflow. Now the question is from a programmer standpoint, people who create computer programs. They are the geniuses. They are the geniuses who create these applications or apps or computer programs that we use. Okay. So for example, right now we are using Google Meet as users. You will use Microsoft PowerPoint or Word as users. But now, how does the journey look for a computer programmer or the person who codes? Okay. There, the flow is different. So there what happens is, we start with what is called a high-level language. High-level programming language. And these are the languages that you mentioned, no? The same one, like C, C++, C, C++, Java, Python. These are called high-level programming languages. And then this is the high-level programming language. Will look close to spoken language, like English. The commands, when you read the high-level program, it can kind of make out what it is trying to do. So that programming language is close to natural language. It's not exactly natural language, but it's close to natural language. And then what happens is this thing it has to be converted into binary, because the computer can only run binary. So there is another program that is written, that's called the compiler. There is a variation of that called the interpreter, and this will be specific for each kind of computer you use. For example, it'll be specific to Windows. If you use a Windows computer, it'll be specific to Mac OS. It'll be specific to Linux. Whatever operating system you use, these compilers and interpreters will be specific to that particular operating system. The high-level programming language you can write on any computer. You can write it on a Mac. You can write it on a PC, and there will be no difference for you. But the compilers that are necessary to convert the high-level language to binary, that is very specific to the operating system. So once the compiler interprets it, then what happens is you get what is called the assembly code, which have the instructions for the processor. The instructions for the processor. And again, this is also very specific. So this will be specific to Intel, for example. Intel will have a set of instructions. Your Mac will have Mac processor will have a separate set of instructions. So now it becomes specific to the processor. It becomes specific to the processor. So these processors run on instruction sets. And this whole thing is called instruction set architecture, ISA. So the engineers working in Intel, they develop and make changes and improve the Intel architecture. Intel architecture is called x86 architecture. That's the name they give. Mac processor, it runs on RISC, reduced instruction set computing. AMD processors also run on x86. So each processor finally is the one which is executing the code inside the computer. So from the high-level language, it has to be translated. That's what compilation does. It translates from high-level language that we can understand to a bunch of zeros and ones. We cannot look at the zeros and one code and make sense out of it. Very, very, very difficult. Very few people can do that. Just looking at zeros and ones can try to figure out what the instructions are. All right. So this is the journey, and it didn't start like this. When computers were first invented, the programming was done in assembly language. I mean, the earliest one would have been in zeros and ones, but that is not practical. So assembly language, obviously, assembly language is not very intuitive to understand. And then engineers they developed high-level languages so that it becomes easier to program. Ultimately, we want to communicate the problems that we want the computer to solve. So the closest to us will be our natural language. So the high-level languages like C, C++, Fortran, Pascal, there are a whole bunch of them. They were all created so that it becomes easy for us to tell the computer what to do. Alright, so this is a journey from the programmer standpoint, the technology people's standpoint, not the user standpoint. User standpoint very easy. You use it, you use the browser or you use the app, and then execute that program. Right. Now, you children, you're all here in the second path. This is the journey. Okay, and within this journey, let me try and see if I can show a picture. It might be more intuitive for you to understand. Just look. Okay. So I'm going to show one image. Alright, fairly straightforward. These are all the things that you're all familiar with, and essentially the parts of the computer. Okay, you must be familiar with. I won't go into these in detail. You would have studied it in your schools anyway. Now, the thing that you need to understand is that this whole thing, usually what happens is this box over here on top, most people call this the CPU. Okay, that box, that big box. But really, the CPU is located inside that box. So the correct name for it is the case. CPU case. And inside that, you'll find one card like this. It's called the motherboard. And on the motherboard is the real CPU. That is where the real CPU is located. You can see it over here, middle. And highlight it. So that is the real CPU. And to avoid confusion with the CPU box, it's also called the processor. Alright. So this processor, you would have heard that, for example, if you're using Intel computers, then you have the Intel core, whatever processor. So Intel makes processors. Another company called AMD makes processors. So Apple makes processors, M1, M2, so on. So these are the companies which make the real CPU processor that is used in computers. Then of course mobile phones, you find other people, for example, there is a processor called Snapdragon. Does anyone know which company makes Snapdragon?
Snapdragon.
So there is a company called Qualcomm that makes Snapdragon processor. So that's for mobile, right? So anyway, this CPU, the real CPU, the processor, that is the brain of any computer or computing system, including mobile phones. That is the thing. And what you are learning in this course, chip design course, is one tiny part of how that real CPU processor is designed. That is hardware. That is hardware. You can touch it, you can hold it in your hand, you can feel it. It's real. On the other hand, computer applications, programming languages, all the software, you cannot touch and feel it. But this is the real deal, the hardware. You can touch and feel it, and you are going to learn how to make this. In fact, I've been coordinating this course from the first edition, 2023. And then last year and now this year. And I've seen that this course itself has been changing. It's not the same course. The first course that went on for several months, and there were 3 levels: basic level, intermediate level, advanced level, and it was much more in depth. And students also had time to understand stuff. Now, in 2025, this edition of the course is so compressed. In 2 weeks, that's it. That's the time you had to get some essential information. It's not sufficient. And then all of a sudden, all of you were thrown one board and said, okay, go ahead, use it, play with it. Without any context. In fact, first level, no boards were given at all, but that had the most in-depth understanding of chip design. Last year was kind of in between. This year it is like some shortcut into this process. And honestly, I am not very personally very happy because I noticed that children have not learned the essence of chip designing. Alright, and many students in the study circle and ALCs, they were telling me, sir, we are not able to understand what is happening here. And many of them felt that somehow they were not getting it, and they were concerned. Like, are other students getting it? Are we the only ones not getting it? We're not able to understand anything. Not being taught properly. Those are the things which students have been telling. That's why I decided to have this session for you guys today. So the thing is, everyone is in the same boat, not able to follow what is happening because it has been too quick. 2 weeks is not enough at all. I mean, and you are all school children. This particular chip design course is a engineering degree level course, and that too for students who finished engineering. It's like a master's level course, chip design. I learned it when in masters in the US. That's even in India it was not available at that time. That is where I learned it. And here even now the college courses are not there for chip design. And you school children from 6th grade are expected to learn and master it. It is not going to be possible because only because there is so much to learn. It is not something that can be compressed into 2 weeks and taught. Alright. So what we are going to do in this is going to be a small group. It's going to be a small group of students who are really interested in chip design, and we will go through it at the right pace. There is no hurry. It's not like after 2 weeks you are going to become a chip designer and you are going to work for some company. You have several years. For engineering students who are looking for a job interview, for them, 2 weeks crash course, learn something and go answer questions in the interview. That is alright. You children are not in that situation. So you can learn properly usually how the first batch students learned.
Here AI can't come.
So we had conducted the same kind of course that time also. Alongside the VSD course, the online thing that you are doing with Kunal sir, I also conducted in parallel. It was long. It took more than 30 weeks to do that. But we went through it in good detail, and the children there learned how to do it. So we are going to do that again, right? So those of you who are interested, be regular to these classes, and you will really learn from scratch how these things are built. And it's not only fascinating, it is in technology. This is considered to be the highest value skill, the highest value skill in technology. To be able to make chips, they are the ones who are paid the most, high demand chip designers, and it requires brilliance. It's not like anybody can
கத்தாத
do it, learn it, or
சரி
do
விடு
it.
விடு
It requires a certain ability.
நார்மலா பேசு
End of the day, what are we doing? We are making a non-living thing.
உங்களுக்கு போகணுமா
Computer is a non-living thing, and that too, the computer chip is mostly made of sand. That is the raw material. So we are making something literally made of sand, do extremely complicated stuff, even faster than human beings. Computations, calculations, stuff. Computers do much faster. We cannot even imagine human beings do it at that pace. So it is a very valuable skill to be able to
இது என்ன
make
sand?
a non-living thing understand computation. See, human beings, naturally we know computation. We know the brain can process numbers, it can understand mathematical language. That naturally human beings have that ability for numbers and counting. But it is still limited in terms of speed, complexity. Of course, animals can't do even that also. Okay, so we are talking about a non-living thing being able to do amazing computation. So you have to really admire and appreciate. Whenever you look at a computer, sometimes you get frustrated. Like, Anya, sir, this GitHub is not, it's crashing, it's doing this, doing that. We can get very frustrated. Even when the computer, when it's doing something, if it shows that loading icon with that circle going around, we get very frustrated. Like, what is happening? We expect everything to be done in like 2 seconds. But just imagine the complexity of what it does. So you children are going to be among the very few children in the world who are going to learn and know how these things are built. Okay, so already you're the third batch. Of course, like I said, the first batch students, they got a lot of time to understand. They had so many activities. So the hope is that in these sessions, the excellence in computing, ESAT sessions, you will all get to do. And we'll keep the group small, not very big. I look for a couple of weeks, see who are all regular. Don't worry if it is not interesting enough for you. Don't worry, you don't have to go through it. All right. But if you're interested, I'll see for a couple of weeks, and then we'll create a separate group for all of us, and we can in Telegram I'll create a group, and then we'll learn more. Okay, so we'll keep the group small so that we can learn in detail in leisure. Right? Great. So this is what you're going to learn. Look at the big picture. Big picture is computer is meant for doing computing, playing games and stuff. But what in the computer is doing it? It is the central processing unit, the CPU, the real processor that is doing it. And you're going to learn one part of how that is designed. And like I said, this is an extremely valuable skill. Okay. So that's the big picture. Vaibhav, did you have any questions so far?
No, sir. Not much. But one last question. Can you tell how do you give codes like those like suffixes they add to those words, right? Like the short words we add while coding. Can you tell those and to give an overall idea about coding in that?
Yeah. I'll do that. Yeah, but we'll come to that in some time. Okay.
And sir, I have one more doubt.
Yeah.
What's the difference between Java and all of those languages, and what is the difference between GitHub?
All right. So GitHub, see Java C, C++. They are all programming languages. So these are high-level programming languages using which you can write computer programs for the computer to do things. So you can code a game, you can code an app. For example, the things that you probably use Swiggy app. So somebody has written that Swiggy app. Those are these programmers, and they would have used a high-level language like Java, C, C++, Python. So these are the high-level languages used to write computer programs. I'll also include Scratch because most of you might be familiar with that. All right. So this is these are high-level languages. GitHub is a repository. GitHub is a repository. Repository means it's a storage place. So the code that you write, you can store it. See, you can store it in your hard disk also, in your computer. GitHub is a cloud repository. Okay, so it's a storage area. In the cloud. Cloud, I hope you understand that this is the computer network cloud and not the cloud in the sky which causes rain, not the cloud. Okay?
Oh, yes, sir, no problem.
Oh, you won't believe so many grown-ups, they still think that cloud computing means somebody has gone and kept their computers in the cloud. Really, many don't know this, alright? But you children, of course, you will know because you have been born with the cloud. Alright, so this is a repository. So what you have to do? You have to create your own account, and then you can create folders just like a computer, and then you can store your whatever computer program, whatever you are developing, you can store it over there. And what is the advantage of GitHub? You can easily share it with other people. If you want other people to look at your code, if you store it in your computer, then you have to email it to them or send it by WhatsApp, whatever. But here, you just have to send them the GitHub link, your GitHub link, and they will be able to open it and see your program. So today, this is how computer programmers exchange their code, they review each other's code. It is through GitHub. So GitHub is an open source repository for keeping your files. It need not be computer programs, you can keep any kind of file over there and allow other people to access it. But it is designed for computer programmers. So the process the computer programmers use to create programs, it supports that process. So that is what GitHub is, and now it is owned by Microsoft. It used to be open public source, but it's very difficult to run open source public source systems. It requires a lot of money. So now GitHub is owned and operated by Microsoft. Right? Understood the difference, Viber?
Yes, sir. Got it clarified.
Clarified? Okay. Girija, yeah, go ahead, Girija.
So can you hear me?
Yes, very clearly. Go ahead.
So what is RV64 and all the different extensions they have, like the multiplication extension and all?
We have not even come to this. All right, when we come to that, I think. Okay. By the way, this one, what we are doing has nothing to do with the chip design, Samsung chip design course you are doing. In the sense that you have to do it on your own. In the sense, it has its own pace. It has its own activities and it has its own deadlines and you have to complete it. So that is on a parallel track. Okay, so that you have to manage. I will not help you with the assignments over there or somebody said, I need help with week 4. I will not even know what week 4 is. Okay. The idea of this one is for you to get a thorough understanding of how computing these things work and to build these things. All right. So this is a deep learning program. Okay. So we don't have any what is the deadline. We can do it at the right pace. So it will be brisk, but I am not going to do any shortcuts all the time. All right, Girija, we'll come to that.
Yes.
Okay. Nag Chaitanya.
So, I have a doubt, sir. So, during programming, we use many thought forms SP and many other forms. So, what are the forms? How can I understand them?
No, what? SP. What did you say? SP.
Yes, sir. Many others, the same. SP, another one. How to understand the meaning and the full form, sir?
I don't know what you're talking about. I don't know what SP is. But if you tell me something specific, then I might be able to.
Sir, I think
I don't know what SP is.
Sir, I think what he means by SP is standpoint.
Stack point.
I don't know what he means.
Or
SP
stack
could mean,
point.
it can mean superintendent of police also. SP, I don't know in what context he's asking. So put it in the chat box, okay? Because I don't know what you're asking. Yeah. Also, I noticed that there are many students who are there who have not signed up for this at all. Okay, they have not signed up. They have not filled the form. One thing I ask you, and I'll be very strict about it. This is meant for only a certain group of students. Just because you have a link to this class, it doesn't mean you can distribute it to anybody. Okay, you have to honor that. So please don't do that, because I see many students who should not even be here in this class. I don't even recognize the names. They have not signed up. They have not used the form. Somehow they have gotten this link from somebody else. And if I find out who it is, I'm going to be very strict, because this is a very clear instruction, and most of you have been in the program for many years, and it's a ground rule that you are not supposed to do this. This is not like, okay, I have a link and I share the link. It is strictly forbidden. Okay. So if you did not get the link directly from me, those people don't belong in the class. I don't even know many of these names. I don't know how they got the links. So please, I'll ask you, if you have not gotten the link from me, please leave the class. All right. There is a proper process for joining these classes. Just because somebody has a link and they've given it to you, it's not. I'll politely ask those of you who have not been given the link to just leave the class. Okay. And please don't share the link. If anybody asks for the link, send them to me. Give them my email address and tell them to contact me and get it directly from me. Please do not share the link with anybody else. I will be extremely strict about that. Okay, it is not right for the other students. So whoever did not get an email from me directly with the link, it means that you have not registered in the proper way. I'll ask you to leave the session. All right, because I just noticed that you should not be doing that. All right, please don't share the link. Okay, so this let us now that you have understood the big picture, let us look at the next thing. So now, see these chips, the processors. These processors, when we look at them from the outside, you cannot even tell what type they are in the inside. Like the chips look like this. The processor chips, they look like this. Squarish, rectangular things, very small. You can hold them between two fingers, thumb and one finger. They're very compact. So just by looking at them physically, you cannot make out at all what it is. Is it a RISC processor? Is it what instruction set it has? Cannot tell at all. The and each one will be different. Each one will be different in its architecture. It is just like a city, and I'll show you one picture now. If you open it up, how it might look like. Let me show that to you. And this you actually have to see through a microscope. You have to see through a microscope. You cannot see with the eyes. You cannot even make out what is inside. So this is how these chips look inside. And these yellow boxes are drawn to highlight different regions. Alright, so when you see this word called cache, see the L3 cache is written over here. When you see the word cache, it means memory. Okay, so that's what it means. L3 cache means memory, storage area. This is L3 cache. Now L1 cache, level 1 cache, L1 cache will be located inside the core, inside each core. This is also memory. And L2 cache can be shared between one or two cores. Alright, so essentially there is a lot of memory available, and then core means the core functionality of the chip. So what is the core functionality of the chip? It does arithmetic operations. Most of the time it will be doing arithmetic operations. Adding, subtracting, multiplying, dividing. And then it also does logical operations. So mainly do only two things. Arithmetic operations and logical operations. So inside the core, there is something called the ALU, Arithmetic and Logical Unit, ALU. Alright, and in the chip design course, we will be focusing on that part, ALU, how the ALU is built. Because it is the heart of the brain of the computer. The brain of the computer is this entire processor. Inside that, which is the core thing that does the computation, it is the ALU. ALU is the core unit. So that is where the design lies, how to design the ALU. See, the computer is a computing machine. Computing means find a number. That is what computing means. Find a number, essentially. So it is it's doing a computation all the time, calculating numbers. Okay, and the more powerful computers means it can handle bigger numbers. See how your PC, laptops, you would have heard of things like 32-bit, 64-bit. What it means is that the size of the data. 32 bits means 32 binary digits. That is the maximum amount of length of data it can support. Like for example, 597. That is a 3-digit number. 81457. That is a 5-digit number. But these are binary decimal numbers. 32-bit computer means the numbers will have 32 binary digits. 32 bits. Bits mean binary digits. That's the short form. Bits is the short form for binary digits. Alright. So the more powerful computers can operate with much larger numbers. So supercomputers, they can go on many more number of binary digits. Okay. So when we started learning computers, that time it was 8-bit were kind of useful for doing some tasks. Smaller than that, not very useful. 8 bits minimum. Then it evolved into 16 bits, then into 32 bits, and now we have 64 bits, which is mainstream. And that is sufficient for most of the kind of competitions that we do. So what you are going to learn in the course is how to design things inside the core of the CPU. Okay. So this is not at all easy. This is not easy at all, and I'll tell you, this is a long-term effort. Don't ever think that in 2 weeks or 2 months you will know everything that is there. No, not at all. It's a long journey, and like I said, there are so many prerequisites you need to understand. That is why it is taught at engineering level, because you need 3 years of engineering knowledge to be able to understand. For getting into engineering and understanding that, you need to have 11th and 12th standard knowledge. To get to 11th and 12th standard knowledge, you need all the way 6th, 7th, 8th, 9th. So all that knowledge can't be compressed into 2 weeks at all. Okay, so it will take a long time. This is not going to be a shortcut course. This is for those who are seriously interested in this, who want to learn it. So it will take time, and we will cover a lot in every class. So you'll have to be regular. Otherwise, the gaps will build up very quickly. And we will have hands-on sessions also. All right. But what I'm saying is, you have to be committed to this course. You cannot tell, sir, at 7:30 I have to leave. Then it is no point. It doesn't matter. Even if there are just 10 people who are interested, you have to be committed. Only then I am going to conduct this course. If there is no commitment, I will not. I have no incentive to conduct this course. Like I was saying, Vaibhav and Anya had joined at 6:30. Many had not even joined at 6:30. And they're asking, where are the others? I said, I don't care. We'll start. We'll get started. 6:30. If you say we're going to start, we'll start at 6:30. But I'll expect that commitment from you in case you want to learn. So don't come to this class like watching a movie or something. Oh, it's interesting. I'll sit for some time and then I will leave. This is heavy duty course. Okay, so it will require your commitment. And if you are not committed, that's all right. No problem. You can do other things. But if you are partly committed, no, it's going to be a total waste of your time. This also you will not understand fully, and something else also you will not be able to do. So attend this only if you are really interested in attending. Okay, and it will be an extra workload. So you will have your Olympiad, you will have school exams, all that will be there. Alongside that, you will have to learn this. If I notice that if there is not too much interest and very less people are participating, then we will stop the course and restart it whenever you will be available. All right. So this is not going to be a shortcut course. Okay, and many questions and answers you will get later. Everything you will not be able to understand immediately. Okay, this is like I said, the most valuable skill. Why is it the most valuable technology skill? Because it is difficult, and because it is difficult, not everybody learns it or has the ability to learn it. Not everybody can learn it. Just because they attend a course doesn't mean they can learn it. They should also have the ability to learn it. And I have seen that children of your age have the ability. Not everybody, but those who have it can learn. In fact, the first batch we even had 5th graders. So we had from 5th grade. We had 5th onwards. In the first batch of this course, chip design, it was sponsored by Intel, not Samsung. Intel course from 5th standard to MTech students, Masters of Technology in Computers and Electronics. They were in the same class, 5th standard to
எனக்கு இன்ட்ரெஸ்ட்
And I've
இருக்கு,
seen,
நோ ப்ராப்ளம்.
I've seen
அப்ப
fifth
நம்ம
graders
கிளாஸ் மாதிரி அதையும் ஜாயின்
outperform engineering students in the
மிச்ச
course.
கிளாஸ்ல
They understood it, diligent.
ஹேண்ட்ஸ் ஆன்லாம் பண்ணி
In
தருவேன்.
fact, some of their notes that they took in these classes, the notes, like, I hope you children are writing down a lot of notes.
நிறைய பேர்
Those notes became like textbooks for the next batch, like that, fifth graders. Sixth graders.
யார் நோட் புக்
In fact, Intel was so impressed that they were willing to give job opportunities. It doesn't matter even if you're in 8th standard or 9th standard. Come join us. We want this kind of talent. So you children will be able to do it, but you need to have commitment.
இப்ப கிளாஸ் நடத்துறாரு.
Any questions on this so far? Yes, Nag Chaitanya, you have raised your hand.
ஓகே.
So can you repeat the what is
பேருக்கு
ALU?
வந்து
ALU.
என்னம்மா?
சாருக்கு சில பசங்களாம் வந்து இந்த இது கிடைக்காமயே சில பேர் இன்னும் எல்லாமே அவங்க ஜாயின் பண்றாரு பாத்தியா?
Logic.
அப்படியா?
திட்டிந்தர் எல்லாரையும் ஒவ்வொரு there in the chip design and fill the form, please do join
that
the
you're
chip
familiar
task.
with. Addition, subtraction, multiplication,
Oh.
division,
Okay.
finding the square
See,
root.
இந்த
All
கிருஷ்ணதேவன்
of
ஒரு
this
பையன் வந்து
number
அப்ப
operations.
கிளம்பிட்டான் பாத்தியா?
That's called arithmetic.
ஓ நான் பார்க்கலடா.
Logic
அன்விதா அவனிதான்
is
அவன்
different.
கிளம்பிட்டான்.
It is mainly finding out true or false. That is what logic is. Finding out true or false. And then inequalities. For example, is some number greater than 2 or not? So if x is 3, then this will imply it's a true statement. If x is 1, it will imply it's a false statement. So logic unit is for doing these kinds of comparisons. Is one thing bigger than the other, smaller than the other, equal to other? So that is called logic. Okay. Logic means arriving at the truth. That is the meaning of logic. And in one of the classes I was mentioning, ancient Indians, they had developed the entire process for logic. It's called Nyaya. Nyaya is the Indian system of logic. Very, very sophisticated. How to understand statements and find out whether they are really true or not. That is logic. And this ability will help those who are into debates to identify positions that are contradictions or fallacies. Alright, anyway, so ALU is that. So let me see if there is a diagram which shows this. That's fine. But did you understand, Nag Chaitanya, what is ALU?
Yes, sir.
Okay. Fine. So next, let me look at. So we did the big picture. Let me look at the topics what we plan to do. Anyone remembers what else we were planning to do?
Sir, we were planning to discuss about the logic gates.
So first one was the big picture of what
NAND and
happened.
NOR.
Yeah, correct. So this is the big picture. All right. So next, we need to understand logic gates. So these. So what is the meaning of this logic gates? Okay, at the hardware level, hardware means something you can touch and feel, the real computer box. Software means you cannot touch and feel, but it is required to make the computer work. So, the hardware cannot work without software, and software cannot run without hardware. So interdependent. At the hardware level, computers operate on electricity. Okay, so it's an electrical or electronic device. So computers are hardware is electronic device. Okay. So when we say the computer is doing calculations, computations, it is being done with electricity. It is being done with electricity. Okay. So at the hardware level, all the computation
நான் இங்கே சாஞ்சன் கேட்கலாமா? இங்கே சாஞ்சன் கேட்கலாமா? நான் ரொம்ப டயர்டாக இருக்கேன்.
done
நான் கேட்பேன், நான் என் கார் மட்டும் நீட்டி
by electricity.
all the computation is done at
So electrons are doing the work. Electrons are doing the work of computation. And there needs to be electronic components to make computers work. Electronic components are needed. Okay, so let me start listing the important ones, because we will need it for the hands-on later. So the most important thing is electricity itself. Okay, without that nothing will work. So that is called the power supply. So the power supply or voltage is necessary. And I will draw the symbol also. So that is denoted like this. So this is the battery. This is a symbol for battery. There is a bunch of standing lines alternating between tall and short, tall and short. The tallest one is it starts with the tallest one. So that's positive, and considerably positive, and then the short, it ends with the short one.
Excuse me, sir.
Negative, yeah.
Excuse me, sir. My laptop had a small internet connection problem. Can you just tell, like, what did you introduce about logic gates?
Yeah. What I was saying was that logic gates, even before we get to logic gates, you have to understand that computers are electronic machines. They run on electricity, and electrons are the ones which provide the energy. And to control the electrons, we need electronic components. So the first most important thing we will need is the power supply or voltage, and that is usually also denoted as VCC. Don't bother about what that CC is, but this is something you will see in the circuit diagram. Alright, so that is the power supply or voltage, and the electronics inside the computer, they require very little voltage. They don't need too much, but they need to be able to recognize two levels of voltage. Because that is how this whole binary language is understood by the hardware. So 0 and 1, that is the binary language. So the 0 of the binary language will correspond to low voltage or lower voltage, and 1 will correspond to higher voltage. And typically this higher voltage will be about maximum about 5 volts. That's it. Low voltage, it can be anywhere between 1 volt, 0 volt. Okay. But there should be some measurable gap between the higher voltage and the lower voltage. Only then these gates and other electronic circuits will work. Okay. So when we plug your computer into the wall, it gets 230 volts AC supply, and then inside the computer there is a power unit which will convert that 230 volts down to this 5 volts DC. So this is a DC supply. It works on DC voltage. DC stands for direct current. I think in one of the classes I have explained this. Alright, so this is the most important thing. Without power supply, computer is not going to work.
So what is the last word in the first line?
Last word to the first line. Computation.
Okay, sir.
Alright. So the power supply or voltage is the most important thing. Then you need electronic components, and the simplest component is called the resistor. The simplest component, and what it does is it adjusts
The current.
the amount of current.
எனக்கு ஏறி கொடுப்பியா நான் கேட்டுருக்கேன் ப்ளீஸ் ஐம் சாரி ஒன்றே பண்ணாக்கிறேங்க
In the circuit.
எங்கேருந்து எலக்ட்ரானிக் காம்பனன்ட்ஸ் are needed.
And the symbol for it is like a speed breaker, because that's what it does. It resists the flow of current, and it reduces the current flowing. Okay, it is used to adjust the amount of current. So this is the symbol for resistor, and resistance is measured in ohms. It's measured in ohms, and the symbol is the Greek letter omega, capital omega. That is the symbol for the resistor. The reason I'm stating all of this is you will need all of this in your lab hands-on exercise activity.
மேல் போகாது நான் எழுதணுமா இல்லையா?
Okay.
Sir,
Then the next one, next electronic device is called a diode. So this is like a one-way device, meaning it will allow current to flow only in one particular direction. It will not allow an electric current to flow in the opposite direction. It allows an electric current to flow only in one direction. See, such a material does not exist in nature. In nature, there is no material that will allow electric current to flow in only one direction. Material will allow electric current to flow from left to right also, right to left also. It cannot differentiate. But smart human beings have invented a one-way device. So this is the symbol of the diode, and if you look at the symbol itself, you can see it's like there's an arrow. So the arrow, it denotes the direction of current. So in the reverse direction, it will not flow. In the reverse direction, it will not.
இது லாஜிக் கேட்ஸ்னா இது என்ன? இஸ் திஸ் அ பார்ட் ஆஃப் த இஸ் திஸ் அ பார்ட் ஆஃப் த
It will flow
உள்ள இருக்கிற
only in that designed
லாஜிக்
direction.
வரல அவர்
these the parts in the microprocessor.
Alright.
லாஜிக்
Then The next one is
Is this a part in the microprocessor?
electronic device.
All logic gates, processor எல்லாமே
Right, so before that,
என்கிட்ட
there's
கீழே
another
மைக்ரோ
device called the
ப்ராசஸர்
capacitor.
அதோட பார்ட்ஸ் இது
அதுக்குள்ள இருக்கும்.
அதான் நான் கேட்க அது
So what? It is it's like a storage tank. It is like a storage tank
இது என்ன
for voltage. Like we have overhead tank, no? We have intex tanks on the roof
It's not
used to store water. Like that, these capacitors are tanks, and they are used temporarily
வோல்டேஜ் ஹை வோல்டேஜ்
store
எப்படி ரெக்கக்னைஸ்
அது அப்புறமா சொல்றேன்.
this electric charges. Okay, and the symbol for that is two parallel lines. Okay, and the unit for capacitance is farads.
Sir, I have a doubt. Like, so is the voltage stored in the capacitor or does it flow in it but it only is present inside the capacitor?
No, it flow in and it will fill up the capacitor. So if you have a 24 volt capacitor, up to 24 volts, it will up to a charge it will store.
Okay, sir.
Okay, you can store it. It's like a tiny battery. You can imagine it like a tiny battery. Even the symbol is kind of similar to the battery and the capacitor. The capacitor, you have two lines of same size. For a battery, one small and one short. And battery can hold a lot of charge for a long amount of time. Capacitors are designed to hold charge only for a small amount of time.
Sir?
Yeah.
So what's the difference between a battery and a capacitor, sir?
That's
Battery and capacitor, the way it works, battery is very sophisticated. There are chemicals in there, the electrochemical reactions happening, and then this voltage is produced. Capacitor is very, very simple. It is just two metal plates. That's it. And in between they keep paper or something. That's it. Very simple.
So, sir,
And by its property, it will store charge or something. It's just a storage device. It does not create voltage. The battery creates voltage. The capacitor only stores the electric charges. It will not create. It's not a power supply.
it's like a battery.
Understood? That is the difference.
Okay, sir. Thanks.
so sir, basically capacitor is like a
One
thing.
challenge, okay, one challenge for this group. You should not use the word basically. Okay, that's the weasel language. Try to practice speaking without using the word basically. And in case you would have noticed I avoid it. But in case I use the word basically, call me out. Okay. Basically is used so commonly and instinctively. It's weasel language. It means that somehow we are not able to speak fluently. So we use basically and all. Many people will keep using basically. It's considered weasel language, and I want you children to avoid using that. Okay. In fact, in many study circles, it's a challenge. And we have practiced, and we don't use basically at all. Okay. So try and do it. In case anyone does it, we'll call you out. All right. Go ahead. What did you want to ask?
So, sir, then the capacitor is like the battery placed in the motherboard or the electric board in which all the components are placed, and the electricity stored in that when it is in motion, like around the microprocessor or that machine.
Yeah, I'm not understanding anything you have said. Ask the question itself, then I will be able to answer. What is the question?
Sir, is the capacitor like a does it play a battery like role in the microprocessor?
No, not at all. See, I told you the difference between a battery. Maybe I'll write it down also. Okay. So, difference between battery and capacitor. And the difference is that battery generates generates voltage. Battery generates voltage. It generates voltage using electrochemical reactions. So special chemicals are needed. We say lithium ion battery. So it uses some lithium salt, lithium metal. Similarly, the pen cells that we use, remote control, that will have manganese dioxide, it will have carbon, it will have special chemicals. Your inverter batteries, it will have lead and acid, sulfuric acid. With that combination of metals and that liquid solution, it produces voltage. That is what battery does. Okay, using electrochemical reactions. Capacitor, no such thing. Capacitor is just like a tank. Okay, is like a where you can fill in electric charges. That's it. So it just store voltage.
So Daddy, all the electricity that is supplied to the microprocessor gets stored in the capacitor and is then used in the entire board. Correct?
Yes, sir.
Yeah. So capacitor is very simple. They just have two tiny metal plates. That's it. And in between they put paper or some ceramic, some dust. And that's enough to store charges. You don't need anything. You don't need complicated chemicals and stuff at all for storing electricity. The property, just having
You
parallel
put a
plates,
mark for the one that I'm
electricity,
asking.
the voltage gets stored there. It's amazing.
We
You will learn it in
in
physics.
the voltage.
Anyway,
Did you read the electrochemical reactions
On the voltage.
used in the battery? Can you name some of them?
No, not in this class. Okay. We are here for learning chip design. There is a separate series of classes called Excellence in Chemistry. There we discuss all those things in detail. Okay. This is just enough for you to understand for the sake of understanding chip design. Alright?
Sir, excellence in chemistry has already started.
Sorry?
Sir,
No, not yet started. Not yet started. I was planning to start that. Then many children were asking me about this chip design. So I said, okay, we'll start with this. Because that will also be on Tuesday. Tuesdays or Wednesdays.
oh. So then, will the excellence in chemistry classes start anytime soon?
December is what I've been planning. Yeah, soon. See, some children are not interested in computers. They are interested in more in chemistry. They'll prefer to attend those sessions. In the study circle, we cover many topics, but breadth, not go deep into them. So these excellence classes, we can go deep and stay focused on one subject. Right? Anya, if you're interested in chemistry, join that. It will be a lot of fun.
Very much, sir.
Alright. The next one is called an inductor. Inductor.
என்னமா நோண்டிட்டே இருக்க
And it's very simple, just like the capacitor. The capacitor is a very simple device. Inductor is also a very
How's
simple
it going?
device. It looks like a spring. And it is constructed like
Can you
that.
keep it aside?
The conductor and
ரெக்கார்ட் ஆகிட்டு இருக்கு
wind.
வார்த்தை கீத்து எல்லாம் பண்ணி காதில் ரெக்கார்ட் ஆகுது
Okay. And then you get an inductor, and what it does is it
Listen to what he's saying.
Listening only, Dad.
that one stores electric charges. This one stores magnetic energy. One stores electrical energy, one stores magnetic. So this is also needed. I used the wrong color for this. This is the inductor. The unit is Henry. Capital H. How much energy stored, you can measure that, right? That is the inductor. Sometimes it's also called inductance. come to the real king of electronic devices, and that is called. Anyone wants to guess? Some of you might have done it before.
Sir, microprocessor?
Nope.
No.
No, sir.
Switches?
Sorry.
The switches or transistors?
Very good. Transistors. Yeah, absolutely. Transistors. This is what makes all of these chips possible. Transistors. Okay. So this is there are two uses for it. It can be used as an electronic switch. The other use for it is can be used as an amplifier. Can be used as an amplifier. Amplifier means increasing the strength of signals. So, for example, you have a volume control in your TV devices, right? So, when you increase, when you turn that volume knob, or when you increase the volume, what happens? It goes through an amplifier. The amplifier is going to increase the volume. That is the electronic circuit which will make the voice louder without distorting the voice. So it just makes the voice louder. When you are listening to music, you want to not relatively increase the volume.
Diode மாதிரி அது
Becomes
இருக்கும்.
louder. So the transistor is what is used to make amplifiers. So,
டிரான்சிஸ்டருக்கு 3 லீட் இருக்கும்.
so this is the king of electronic devices, the transistor.
செலக்டர், எமிட்டர்,
And
பேஸ்.
there are many different types of transistors,
இப்படி இருக்கும் சிம்பிள்.
but I'll just draw one of them. Okay.
PNP,
This is a common one that is used called the
இது NPN.
junction transistor,
பேஸ் எமிட்டர் கலெக்டர்.
bipolar junction transistor.
கலெக்டர் எமிட்டர்.
This is not used too much these days, but then this is the standard symbol that continues to be used. And there are no units for transistors. It's just a device. Inductance, there are units. Capacitor units, battery, voltage, there are units. Current, there are units. But for diodes, no units. It's just a device which allows current to go only in one direction. Transistor is a switch, and there are three terminals. Transistors have three terminals. In this particular type of transistor, they are called the base, collector, and emitter. I'm just naming it. I'm not explaining how a transistor works, how it's made. I am only showing you what it's going to be used for and how you can use it, how you can recognize this symbol. But this is the king of devices. And in chip design, we are only going to be using transistor as switches, not as amplifiers. We are only going to be using it as switches.
டிஜிட்டல்ல டிரான்சிஸ்டர் will be switch.
சரி தெரியும்.
டிவி அந்த மாதிரி இதுல it's an amplifier.
Transistor as a switch, and how it works. See, it's like a regular electric switch. For example, turn on a light or switch on a fan. You go to the wall and press that switch, and then the bulb lights up or the fan starts spinning. But you have to go and press. You have to go and press. This transistor, it can be controlled using electricity itself. You can turn on and turn off the transistor using electricity itself. And that is what makes computers possible. Because when you write computer programs, we talked about it, from high-level language, then compilers, assembly code, and then finally machine language. when it comes to machine language, it's all zeros and ones. So what is there in that zeros and ones? One part of that zeros and ones will be data, information related to something. For example, you want to add two numbers, 5 and 7 you want to add. So 5 and 7 will be data. Okay. And will be the operation to add 5 and 7. Okay. And the answer should be 12 and should come out as 12. So you have to give data as 5, another piece of data as 7. But to make the addition, you are not going to sit and add, no? It is these transistors which are going to do it. These transistors are the ones who are going to do it. And the instructions for the transistors will also be in the form of 0 and 1. So 0 will mean transistor turn off, 1 will mean transistor turn on. So 5 volt will be applied if you want the transistor to turn on. If you don't want it to turn on, you apply 0 volts. So this turning on and off of transistor is done electronically with electricity itself. And this is at the crux of computing. This is at the crux of computing. If this had not been possible, we would not have electronic computers. Electronic computers work because it is possible to turn on and off the switches, electronic switches, on and off using electricity. Not mechanical force going and pushing it, none of that, just by electricity. And how do you make the electricity turn on and off? You write the computer program. So in the computer program, if it results in code like 0110, it means that, okay, now turn off the transistor, next turn it on, again keep it on, turn it off. That is what the 0 and 1 really does in competition. Okay, so that is the crux. That's why this is the king of electronic devices. Okay, and this you will need to remember. The next thing is logic gates. Once we do logic gates, the first thing you children will ask is, okay, now fine, I understood logic gate. How do you create logic gates in the actual computer? How do you do it? For that, you need to use transistors. You have to use transistors. There is no other way of creating logic gates or binary computers. This is the electronic component. Okay, so transistors. Like I said, there are many types of transistors. You will read about them. I mention it also. But all of them work in the same way. They'll have these 3 terminals. And what happens here is that I'll just give it as an example. If B
I'm listening, but I can't write.
B stands for base, okay? Base. If B is kept at 0 volt, 0 volts, then no current flows between C and D. C
Excuse me, sir.
1 second, raise your hand and keep. E stands for emitter. Alright? So between C and D, if you want current to flow, which means you want to turn on the switch, then you have to keep B at high voltage. If B equals high, which is higher voltage, then only then current flows. This is the most important operation. This kind of thing is also not known in nature. This is an engineered device. Brilliant scientists have
chocolate
engineers
pattern
have
and
created this.
இங்க வந்து
This is at the heart of computer. Now, I showed you pictures of the inside of the processor. You cannot even make out it. Just a
షార్ట్లీ బ్రైట్లీ
bunch of colors. That's what you can see. What really is inside the core, especially, it is millions and millions and millions of transistors. In fact, these days, the latest Intel chip, it contains
And
over a
1950s they
billion
were your age.
transistors. Over a billion transistors, all packed in the
So,
tiny
what
area.
age were there that time?
நான் பிறந்திருக்கேன்
More transistors,
What age were they that time?
greater ability. That's what it
10
translates to.
years back since they were
So this is the device. This is the
one
key
person
device,
died.
and you just need to know how it operates as a switch. You keep the base at low instead of 0 volt. I'll just write that also as low.
அப்புறமா காமிக்கிறேன்
If base equals low means lower voltage. Then no current flows. If base is kept at high, then it's almost like somebody has turned on the switch, and now current flows through it. This is the crux. Remember this part, okay? This is what is going to be used to make logic gates. Later we will learn. Okay, somebody had a question. Always raise a hand and keep. Then I can call out. Somebody asked me to excuse them. Who had the doubt? No doubt? Alright. Okay. So that's it. These are the components that we will need to create, to learn to create computer chips. Any doubt in this so far before we move forward?
யாரும் ஆட்
Any doubts? Anybody? No doubts? Can we move forward? Yes or no?
Yes, sir.
Alright. Okay. Sometimes I don't know whether my audio gone bad. Thank you. Alright. So next we have to learn this this Boolean what is that? Logic gates. Logic gates. And I want to do it in a way that your children understand, because otherwise it's very dry, this thing about logic gates. So I want to do it in a way your children are able to understand. I'm just thinking of analogies to use for you guys. Okay. Logic, see, the word gate is there, no? You imagine it like a real gate that you're familiar with, the physical gate in the front of the house or something. So what is the gate do? The gates are used to let things in or stop things from coming in. That's what gates are, right? Gates are used to either stop things from entering, or allow things to enter. Okay. In the situation of computers, like we learned that these are all electronic devices running on electricity. Here it means when you say things, it is electricity. So essentially, gates are used to determine should electricity flow, should current flow, or not flow. Okay, so that is the thing, and there is an entire branch of mathematics called Boolean algebra that has been formulated to deal with this logic, binary logic. Okay, so this Boolean algebra was developed even before computers were even imagined. Boolean algebra was developed in the 1800s by a mathematician called George Boole. He had no idea that it will be used in computers and stuff. He just did it as an exercise in logic. Okay. So an entire branch of mathematics called Boolean algebra was developed now that is used to figure out whether current should flow or not in an electronic circuit. Essentially, that's what it does. Okay. So there are different types of gate. Okay. Different types of gate. Essentially, the gate either should be open or closed. That's it. There are only two cases. There is not like gate is half open, half closed. No, either open or closed. If it is open, it means current can flow. If it is closed, it means current cannot flow. If it is open, the gate will have a higher voltage. High. If it is closed, it will have 0 volt. All right. So there are different types of gate. I will do it in a slightly different order than it might have happened in the class. So the first one is OR gate.
OR. நீ படிச்சிருக்க உனக்கு தெரியும்.
தெரியும். 1 or 0 is 1. 0 or 0 is 1.
OR gate
means
something like this. See, imagine you have two windows. Okay, two windows in your room, and you want to know if some thief enters your room. Okay, and so you have a burglar alarm. And how should that burglar alarm work? Well, there has to be some logic. That burglar alarm should go off when the thief enters from the first window. It should go off if the thief enters from the second window. It should also go off if two thieves come and they get in through those two windows. In all these situations, it should go off. But if no one is entering, it should stay off. Understood? Burglar alarm, how, if you just imagine, two windows are there and what is the logic for the alarm to work? So you create that logic. So that is called the OR logic or OR gate. And it is denoted simple like this. Okay. So X and Y are the inputs, two windows, and Z is the output, the logic. And how does the thing work? You have X and Y as the input, Z as the output. In this case, what should happen? If X is 0, no one is entering from the first window, no one is entering from the second window, then alarm should be off. If somebody enters through the X window, no one is entering from the Y window, alarm should go, should turn on. Now, if and you should pay attention and see if I am producing some inconsistent output. So no one is entering from the first X window, no one is trying to enter from the Y window, then the alarm should go off. Similarly, if someone is entering from the first X window, no one is entering from the Y window, then also the alarm should go off. What about two people entering? Then also the alarm should go off. So this is called the OR gate. Okay, this is called the OR gate. And it is denoted with the symbol plus. So we say Z equals X plus Y. This is how it is denoted. Okay, this is the OR gate. Everyone understood what is the OR gate? See, there is a decision going on here, whether that Z gate should open or not, or the alarm should sound or not. That is the so what is the logic for that? The logic should be if no one is entering from the X gate, but X input, no one is entering from the Y side, then the alarm should not go off. We say that X or Y, when X and Y are 0, then the output Z is also 0. Did everyone understand this? Everyone? Are you clear before I go to the next gate?
Yes, sir.
Alright. Okay, great. Thank you. The next gate is the AND gate.
இந்த மாதிரி உட்கார்றதில்ல
AND
ரொம்ப
gate.
தப்பு பண்ற.
Again, this is the logic gate. And how does the logic work? Again, two inputs, X and Y.
உட்காருங்க. தூக்கம் வருதா அவனுக்கு?
நீ இன்ட்ரெஸ்டடா இருக்கியா இல்லையாடா?
இன்ட்ரெஸ்ட் தூக்கம் வருது எனக்கு அவ்வளோதான். ஐம் இன்ட்ரெஸ்டட். எனக்கு இன்ட்ரெஸ்ட்
And the output Z, let us see how
மூஞ்செல்லாம்
it
மூஞ்சி
works.
அலமே நான் அப்போலேன்னு சொல்லிட்டு இருக்கா கேட்டுட்டே இருக்கு.
போரடி ரொம்ப
In this case,
இஷ்டம் இல்ல.
if
இஷ்டம்
inputs
இல்லைன்னா என்ன வைபோ? That's how you
X
become
and Y
active, right?
both are 0,
Don't worry, I'm listening.
இன்னைக்கும் PE
output is 0.
No, நான் கூட
X is 0, Y is 1. Then also
ரொம்ப
the output is 0. X is 1, Y is 0. Then also the output is 0. When X is 1 and Y is 1, then only the gate Z will open. Okay, both should go on. X also and Y also. Then only Z will. So this is called the AND gate. The name itself suggests. X input should be high and Y input should be high. Only then Z output will be high. Okay. So this is written as X dot Y, like multiplication. And you can kind of see it. See the OR case, you try and add it and see 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 0, 1 plus 1, of course it says 1, but that is binary addition, right? What about AND gate? X into Y is 0, so 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0, 1 into 1 is 1, alright? So that is the logic for AND gate. And you should be thorough with these gates, in the sense, in your mind, when you imagine an AND gate, this table should come to your mind immediately. So this is called the truth table. These are called truth tables. These tables these are called truth tables. And you should know the truth tables for all of these gates. They are not difficult at all. If you want to ask something, please raise your hand and just leave it on. I will call out, okay? If you want to ask something. Don't be turning on the microphone, turning it off, turning it on. Very disturbing. Alright. So these are called truth tables. So in Boolean algebra, whenever the output is 1, that is true, true state, true. That's why it's called truth tables. For what values of the input, the output is a 1. The truth table tells that. And the logic of computers are built on these truth tables. So 2 gates we saw. Then we come to today. What's the time? Okay, we'll be able to finish all the logic gates. The next one is called the NOT gate, or it's also called inverter. Inverter gate. And this is a very simple gate. Very simple gate. It only has one input. It only has one input and one output. By the way, all these logic gates, though, they will always have only one output. You will not find more than one output. You will only have one output. But inputs can vary. It can be 1 input, 2 input, 3 input, any number of inputs you can have, but the output can only be one. Only one gate. See, ultimately you want to know whether the current flows or not. So in the output, if you have multiple gates, then it becomes very complicated. Current can go through the second or third gate if it is open. You don't want that. You either want it to flow or not flow. So only one gate can be there at the output. Letting things in, that doesn't matter. There are different uses. So this particular gate, only one input X and one output Y, Z. And what does the truth table look like? This is a similar truth table because only one input. When the input X is 0, Y will be not X. So that will be 1. If the input X is 1 or high voltage, output will be low volt, 0. That's it. This is the NOT gate. And we write in symbol, we say Z equals not X, like this, put a bar on top. Okay, and then there is a similar, another simple gate, single input gate, and that is called the buffer gate or identity gate. And the symbol for that is just this triangle. Whatever X is, that is the same as that. If X is 0, output that will be 0. When X is 1, output that will also be 1. So this is the buffer gate. We'll ask, why do we need this gate? And there are uses for that.
What is a buffer gate?
Okay, and in terms of symbols, Z equals X. That's it.
Sometimes
Okay, so these are the 4 elementary gates. And then there is a very interesting gate called the XOR gate. XOR gate.
இதனுடைய பவர் ஜாஸ்தி இருக்கும் கேளுண்ணா.
Sir, can you once again repeat what is the use of the buffer and identity or identity gate?
I have not explained at all, so I'll explain it when we come to it, okay? Why we need it. I have not explained it. So XOR gate.
Exclusive.
This is a variation of the OR gate. Okay, so it also looks in symbol like
One and the
the OR gate,
one and the
but then there is one more
exclusive or
drawn like this. This is the XOR gate.
XOR.
See when the OR gate, the first one that we saw. Look at the truth table. What do you see in the truth table? At least one of the inputs should be I or one value. At least one of them, either X or Y. Alright. In XOR, it's a special kind of gate where the gate will turn on only if the inputs are different. Meaning, the X input should be different from the Y input. Only then it will turn on.
0, 1 or 1, 0.
If both X and Y inputs are the same, then it will not turn on. Okay. So that is called the exclusive OR gate. Okay. XOR, exclusive OR. That is the
You need data, na?
25 and
So what is, excuse me, what is the truth table for that? Anyone wants to tell the truth table? Raise your hand. You want to tell the truth table for the XOR gate?
0, 0, 1 is
I'll write the input values that came. X is 0, Y is 0, X is 0, Y is 1, X is 1, Y is 0, X is 1, Y is 1. And what I want you to do is tell the output. Alright, Krishnadev, all yours, go for it.
Thank you, sir. Sir, 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0.
Perfect.
Okay, sir.
Everyone understood? This XOR gate?
Sir, I do not understand.
So, Krishnadev, can you explain?
Yes, sir. So the gate, the Z will only be 1 if X and Y are two different values.
Excellent. Now look at the truth table and verify that what Krishnadev said was correct or not. X and Y have to be different values in order for the Z to open, for Z to be true, for Z to be 1, for Z to be high. So only in the case where X and Y are different, the gate will be open. Understood? Everybody understood? XOR.
Kenna.
Vaibhav, you have raised your hand. You have a question? Nag Chaitanya, you have a question?
No, sir. Like when you told for that XOR gate, like you wanted to answer, so that's why I raised my hand.
Alright, okay. So now,
Sir, can I answer for X and gate or something?
hang on 1 second. Now there is another family of gates. Now all related to whatever we have learned. Okay. So we have what is called the NAND gate. NAND gate. It stands for not and. NAND gate. And it is.
Sir, it's basically the opposite of
One second. If you want to say something, please raise your hand. This is called the NAND gate. So whenever you see that little bubble, it means there is an inverter operator or a NOT operator. Okay. Yes, now Anya, go ahead. You wanted to say something.
So all I was saying is that NAND is basically the
Hey,
opposite of
basically,
AND,
what is
but
the
in like
what is this basically? What basically are you talking about? No, basically.
daisy.
Yeah, get rid of that basically habit. You will be appreciated for communication skills. You won't use basically.
Yes, sir.
All right. So I am writing the input. So you guys complete. Who wants to complete the
So me, Vaibhav,
truth
can I?
table? Vaibhav, you want to do that? Yeah, why not?
Yes, sir.
Okay.
So first one is 0.
One second. I want to do this. Let me just draw this. Vaibhav, you can do it, okay? But I
So
want
1
to
में 0.
draw one more column.
This is 0 only. 0 and 0 is 0 only. Sir, can I do?
Not here. 1 second.
Sure, sir. Huh? 110.
Yes, 1 second. Okay. So what I just so that it's easier to understand, I am first we will do z equals x and y,
First.
and then z equals NAND, which is not x and y. Okay.
0 and
All right.
1 is
Vaibhav,
0.
all yours. First do the AND case.
Asking.
0 and 1 is 0, right?
0 and 0.
0.
Okay. Next 0 and 1.
0.
Okay. 1 and 0.
Again 0.
Okay.
1 and 1 again is 1.
1. So now tell the NAND case.
So the NAND case, sir, basically is the opposite value of
What
the
did you
answer.
say?
Basically.
Sir, I shall not
Okay.
always.
Yeah. I'll call you out. Okay. So till you guys get rid of that habit. It adds no value to the sentence. Continue.
So, sir, opposite of AND is NAND.
Not opposite. Not an opposite. It is not and. See the name NAND is not and.
So,
Okay.
sir, 0 and 0 it will become 1 here,
Very good.
and 0 and 1, which is 0, becomes 1.
Not 0 and 1. Not 0 is 1. Not 0 is 1.
Not 0, not 0 is 1. 1 and 0, which is 0, becomes not 0, which is 1. And 1 and 1 becomes 1, which not 1 becomes 0.
Excellent. So that is the truth table of NAND.
Yes,
Not
sir.
and.
Call it Paityo.
Excellent. Good job. So Z equals
Sir,
not
காலர் நீங்க
X
ஜோஷ்ல
and Y.
இருக்காதீங்க சார் எல்லாரும் என்னை
That is how
பார்த்து
you-
சிரிப்பாங்க
You write it in Boolean algebra. There are the Boolean algebra notation. Z equals X and Y and then put a bar on top. That is the Boolean algebra.
Sorry.
And we will be doing a lot of Boolean algebra.
Basically சொல்லாத
That is the most important thing you need to understand for designing these
No,
chips.
not அது
You
ஏன்டா
know Boolean algebra
நான் அதை
thoroughly
யூஸ் பண்ணிட்டு
and we will
இருக்கேன்.
have many
ஏன்டா
activities
இவன்
related to
ஒருத்தன்.
that. All right.
போட்டு
The next one
கெடுத்து விட்டு
is going to be NOR gate, NOR,
ம்.
which is not or. Okay, who wants to do that? Not
So can I do?
who?
So not Chaitanya.
Okay, sure, yeah, why not? So first let me draw that gate. So it is an OR gate and then you have this bubble. With this, there is a NOT attached to it. X, Y, Z. Z. Here also we will do the truth table for Z equals X or Y, and then Z equals X or Y, not of that. Okay, and I will write down the input values 0, 0, 0, 1, 1, 0, 1, 1.
இப்போ சொல்லி இது என்னது முதல்ல சிம்பிள் ஆர்கி
0 0 0 0 or 1 is 1 1 or 0 is 1 1 or 1 is 1
இது
Alright,
1
go for
it's
it.
1
Now check.
0
Yes, sir. So 0 or 0 gives us 0.
Alright,
0 or 1 gives us 1.
okay,
1 or 0 gives 1.
okay,
1 or 1 gives us 1.
alright,
Sir, so this is for OR gate. So we are going to do the next one is NOR gate. So as we know that X or Y is 0. So not of 0 is 1.
very good,
Not of 1 is 0.
okay,
Not of 1 is 0 again.
okay,
And again not of 1 is 0.
awesome, that's it, NOR gate. And finally, to complete this, what do you think is left? What is the gate that is left?
exam gate huh?
It is XNOR gate.
எக்ஸ் நார்
So what do you mean by X NOR gate?
I am writing, if you just
And
wait for 2 seconds, you will know. XNOR means not XOR. Alright.
so can I
Yeah,
answer
yeah.
for this?
Anya, you want to do it? Alright, yeah, why not?
I just wanted to clarify that XNOR is the same as OR because it's not of OR, and then like again the opposite of not like NOR, right?
No, not of OR, it's not of XOR.
So yeah. So then okay.
See, you remember the XOR gate? See, like this, Anya, we do the gate.
Yeah.
Yeah? We have XOR. So here, you put a bubble, so that is XNOR. Okay.
Yeah.
Yeah. Why don't you try it? Yeah, I want you to try it, Anya. Okay. So we'll do it the same way. X, Y, then Z equals XOR X XOR Y, and for that the symbol is a plus inside a circle, and then Z equals
Daddy X or XOR இங்க பாரு X or gate க்கு if both the symbols are
Alright,
same
let
only
me
it will come, right?
quickly draw this.
எக்ஸாருக்கு போத் சிம்பிள் சேம் லைக்
One.
டிஃபரெண்ட்டாக இருந்தால்
1 and 1 0 and 0 இருக்கணும்
அதில் சேமாக இருந்தால் இது டிஃபரெண்ட்டாக இருக்கும்
1 or
என்னடா
So x0 y0 v is equal to x or of y.
I will help you tell it easily. Okay, so do like this. Tell it as 0 XOR 0. Whatever it is. 0 XOR 1, whatever it is.
XOR means
One
both the
XOR
symbols need to be
zero,
same
whatever
huh?
Then 1 XOR 1,
opposite
whatever
if
it
they
is.
are
Tell it like that,
different
it'll be easier.
then only
Alright.
output will be present. They are same,
I didn't
output
get
will be
what
zero.
you said, sir. Like I didn't understand.
Sir
Okay.
can I answer this Viber
No, Anya has not understood, so we will make her understand. Okay.
okay sir
So Anya, you remember this XOR gate, the fifth one we did?
Yeah.
Yeah. So there, I will forgot to write the Boolean algebra expression z equals x XOR y. Okay. So how do you read this truth table? 0 XOR 0 is 0. 0 XOR 1 is 1. 1 XOR 0 is 1. 1 XOR 1 is 0.
Oh, okay.
Got it?
Now I got it.
So now do the same thing for the XOR part. What is 0 XOR 0?
0 XOR 0 is 0.
Check.
0 XOR
Hang on. Check. Go back to the truth table of XOR. Fifth
Oh,
one.
sorry. 0 XOR 0 is 1. 0 XOR 1 is 0. 0 XOR 1 XOR 0 is is 0 and 1
Where are you
XOR
reading?
1
See here. Go to the fifth one. 0 XOR 0 is 0 XOR 0 is 0. 0 XOR 1 is 1. 1 XOR 0 is 1. And 1 XOR 1 is 0. Remember, in XOR gate, the two inputs have to be different. If they are the same, it will be 0. The output will be 0. Okay? So we can. So only in the case where the inputs are different, it will be 1. Now continue. What is the not of this?
So the not of 0 is 1. Not of 1 is 0. Not of 1 is 0 and not of 0 is 0. 1.
Perfect. That's it. This is the truth table for the XOR, the XNOR gate. Understood?
நான் நல்லா ஆன்சர் பண்றேங்க.
Yes. No.
Yeah.
ஆன்சர் பண்றேன்.
All right. Okay. So among these 8 gates that we have studied today, 2 of them are very special. Anyone who has done the course before, remember which are the 2
Sir,
very
is it?
special gates and
Sir,
why
can I
it
have a
is
guess?
so? Yeah, you can guess. Go ahead.
Sir, is it the XNOR gate and the XOR gate?
No, not them.
Sir, is it NAND and NOR?
Who said that?
Sir, Amrita.
Vinita, you're absolutely right. What a smart child. All right, yeah, absolutely. And why is that?
Because it feels like it's like combined by many gates. Like it's a combination of other gates.
No. That many of them are. No, even XNOR is a combination. But what is special about NAND and
Then universal operators.
not operators, gates?
These are universal gates.
Yeah, correct. What is the meaning of that? What is the meaning of universal gate? Anyone? Anya?
You see
No.
this is
No,
the
what?
one, all these.
Alright. So universal gate
Sir,
means
can I
that
tell?
using no parent help and all. Okay, I want only students to be telling. So using NAND and NOR, all other gates can be constructed. All the other gates can be constructed.
நீ பேசுறதுனால தான் ஒரு ப்ராப்ளம். சும்மா இரு.
நீ அதை ஆன் பண்ணுச்சே என்கிட்ட கேட்டுட்டே அங்க
நான் பேசிட்டு இருக்கேன் நீ என்ன
Alright. So you can it means you can make we can make
உட்காரல நெக்ஸ்ட் டைம்
a NAND gate. Make and
சும்மா எல்லாத்துக்கும் பேசிக்லி சும்மா ஓவர் எக்ஸ்பிரஷன் கொடுக்காதான் சொல்லுவேன்.
using a bunch of
உட்காரது நான் சொல்ல.
NAND gates.
நீ உனக்கா வேணுச்சே கேட்குறேன் அப்போ நான் என்ன பண்ணுறது அங்கே பாதி
நான் சொன்ன பேசாதுன்னு நான் கேட்க மட்டும் நீ
We can make a OR gate using a bunch of NAND gates. You can make
எழுத மாட்டேன்
a NOT gate using a bunch of NAND gates. You can make
அப்படி இப்படி
an
சேஞ்ச்
XOR gate. You can make an XNOR gate. You can make a NOR gate. You can make all of this just by using a bunch of NAND gates. Same thing with NOR also. gate, using a bunch of NOR gates, you can create all the other types of gates. So these two are called universal gates. They can be used to make other gates. And this is what is used in the chips. Because they have to just fabricate one type of gate. They don't have to fabricate or separately and separately. They can just fill it up with thousands and thousands of NAND gates and then combine the NAND gates to make other gates. In fact, there is a chip readily available. Let me see if I can find a picture of that. Yeah. So there is a chip readily available. If you look at it, it's a package of 4 NAND gates, and the chip looks like how it's shown at the bottom. It's a plastic case and it'll have these metal legs. So there are 7 metal legs on each side. And inside there are 4 NAND gates. So with this chip, having a bunch of them, you can create all possible logic gates. You can not just single logic gate, but combinational gates, or combinational logic. Any imaginable gate situation you can create using just this chip, a bunch of these chips. Alright, so this is why it's called a universal gate. Only NAND and NOR have this property. So using NAND and NOR, you can create. And this is also a nice activity. We did not. Did you guys do it in this year's chip design? Of course, week 1 and week 2. Did you use NAND gate and create all the other gates?
No, sir. We only made a very simple circuit, like with battery, GND, a ground, a VCC, and an LED, nothing else, and a fuse switch.
Sir, and XOR gate, XNOR gate also is not there.
Yeah, we didn't use gates this year.
Yeah, so first year we did so many hands-on activities. So we will do that, okay? But did you all understand whatever we learned so far? Is everything clear?
Yes, sir.
Anyone has any doubt? All right. In that case, this is a good place to stop. Of course, there are many other things that you wanted to discuss. But for the sake of completeness, because you children asked those questions, at least quickly let me give you some answer. So what were the questions? A big picture of what happens. We did that. Why are the logic gates necessary? We did that. How are logic gates created on the chip? They are going to be created using transistors. We will learn about that later. Then what is special about RISC and what is FPGA used for? Alright, so these two we will do very quickly. At least you will have some answer for these, and then we'll continue in the next class. Okay. So what is special about RISC? RISC. So RISC, by the way, it is not V, okay? It is 5. This V is for 5th generation, Roman letter V. Okay, so it is not a Roman numeral V. So it's 5th generation, that's what it means. The RISC, this development is started long back, 1970s onwards, will be there. By the time it was 2000, 1990s, it kind of began to become popular, and now it has peaked. So RISC, so this 5th generation, RISC stands for Reduced Instruction instruction set computing. That is what RISC stands for. And RISC-V is fifth generation RISC. So what does this mean? See, the processors, the CPU, the processor, it can only execute a certain number of commands. So there are a fixed set of commands. So for example, there are a bunch of arithmetic operations: add, subtract, multiply, divide, a bunch of. Then there are a bunch of logical operations. Is this greater than? Is this less than? Those kind of things. So like that, only a bunch of operations a processor can understand and do. All right. So computers based on Intel processor, AMD processors, they use something called CISC, CISC. This is complex instruction set processing. Computing. Okay, CISC. So what it means is that these are the mainstream computers. People using personal computers. This is the mainstream, and this has developed in one particular way. The processors used for that has developed in one particular way, which is make the every generation make the processor execute more commands, create new commands. That is complex in instruction set computing. So these kinds of processors, they can execute about 1,500 commands. 1,500 commands, more than that, have been defined for these processors. Okay, the latest ones. This is complex instruction set computing. There was a separate movement by another set of engineers who felt that these processors should be kept as simple as possible. So they looked at all the commands, all the instructions in the complex CISC processors, and then they said, what are the most important, most necessary, what are the most basic instructions necessary, and then they identified a set, that's the reduced set, that's the reduced instruction set. So the core of the reduced instruction set, it just has less than 100 instructions or commands. Okay, so that's the difference between RISC and CISC. That's it. That's the difference. There is no nothing else. RISC means reduced instruction set, and it's a different architecture compared to complex instruction set. Complex instruction set processors are extremely complicated, and they are faster than RISC processors. The reason they are faster than RISC processors is because the commands are already built into the processor. So in the RISC processor, what you have to do for complex instructions, you have to combine several of the reduced instructions, and then you get a complex instruction, which means it is going to be slower. It is going to be natively slower, but the flexibility is higher. For example, if you are designing a computing system to do only certain limited things, there is no point in putting a CISC processor in it, because you are not going to use much of the commands. That is why RISC processors were developed. It is like going to a restaurant, junk food restaurant, McDonald's, and if McDonald's says that we have burgers, we have fries, we have Coke, we have this, that, but then you have to buy everything. That plate will have everything. It will have burger also, this also, that also. Everything will be there. and it will cost so much. That is complex instruction set. But you go to another place where you can say, I don't want fries. Just give me a burger and something. Um, Only the things that you need. That is a reduced instruction set. Okay, so that is the difference. So reduced instruction set now has become very important and popular, especially after the Ukraine war. After the Ukraine war, what happened? There were sanctions placed on Russia. American and European companies said, we will not give you these complex instruction set processors because they are proprietary, and we will not allow Intel and AMD to sell their processors to you. RISC, on the other hand, is not proprietary; it's open source. It is maintained. It was maintained by University of California, Berkeley, which is where Shankar is studying. That's the same university. They made it. Now they have moved it, shifted it. It's now based in Switzerland. It's a neutral country, and this is open source. So anybody can download this instruction set, and they can create their own processes based on that. They can create their own processes based on RISC, and it is going to be safe from US sanctions, because who knows, tomorrow US may say we will not sell complex computers to you. So every country is trying to make their own, every major country. So Russia is making its own RISC processors, China is making its own, India is making its own RISC processors to safeguard against any US sanctions. Now RISC has become more popular, even though it might be slightly slower. It doesn't matter. People say this reliability is very important, and it's like a buffet menu, meaning you can pick whatever you want. So somebody, I think Girija or somebody, I don't know if she's there in the class. Girija, you asked one question. No, Girija is left. So she was asking about that RISC something. Instructions. RISC comes like that. There is the core RISC, which will have all the essential ingredients, all the essential instructions. And then if you want some more advanced instructions, for example, you want to have decimal point operations, large numbers, and so on, then you can get the next increment. So you can pick from the menu. That's what it is. So RISC G will meet the core functionality, or the most important functionality that most people will need. That's all packaged into RISC G package. And then there are other alphabets used for add-on functionality. So that is RISC versus CISC. Did everyone understand that? What is special about RISC? Any doubt? No doubt? Okay, finally, very quickly I will explain what is FPGA, and then we will end the class for today. Alright? So FPGA. Anyone knows what it stands for? I'm sure those who got the card will know. What does it stand for?
Sir, field programmable gate array.
Very good, Krishnadev. Did you make sense out of it? What it really means? What it would mean?
Not exactly, sir.
No problem.
Thank you, sir.
Yeah. Gate array. Okay. So we'll start with the last two words. Gate array. It essentially means array of gates. And array means it is like arranged like a table, rows and columns. Of gates. And then field programmable means that the user who buys user who buys this chip, the FPGA board, can program however can program it for any use. You cannot do that with directly with RISC or with CISC. How many of you have played with Arduino? That board. It's a microcontroller. You can do amazing things with it. You can stick sensors to it. You've done it, is it? Vaibhav and Krishnadev?
Yes, sir.
Yeah.
Yes.
Yeah. So this, so there, what would you do? You would connect it to your laptop or computer, and then you write code. It will look like C or Python, and then you can click on a button, and that code will download to your Arduino board, and then you can unplug that Arduino board and you can use it. We have downloaded. FPGA is exactly the same like that, except that there in FPGA you don't write the code like you write in Arduino. In FPGA you have to tell how the wiring is done. See, in your Arduino board, when you flip it over, you can see the wiring is already done. The components are all interconnected and it's ready to be used. All you need to do is write the program and run it. FPGA, the wiring is not done at all. So it is just a bunch of logic gate blocks. You have to do the wiring. You have to do the wiring. The thing is, you don't have to sit and solder the wiring. Okay, you don't have to do that. There is another language you need to use. It is called HDL, Hardware Definition Language. Using hardware definition language, you can tell how to connect the wires of the board. So when you get the FPGA board, it will not be configured. The chip will be just black. But it will have the ability to for you to connect however you want, and then you can erase that connection, redo another connection for another purpose. You can completely customize it. That is the beauty of FPGA. Now the squadron board that you got, the FPGA part is just one that in the middle, that square chip. That's it. The rest of it is used to do some activities. That's all. But that, so let me show you the schematic of FPGA. So the FPGA will look something like this.
Random one.
So it looks like this. It's an array, meaning it's like a grid. It's a grid of whole bunch of logic blocks. And you can see some lines. Those lines are nothing but the connections. And you can program these lines, how you want those lines to be connected. That is programmable. That is the power of this FPGA. That is the programmable part. Okay. So you can connect. Oops, I lost it. I was trying to resize it, but it was not allowing me to do it. Alright, so it's like that. So a whole bunch of logic blocks arranged in rows and columns, and then that IO stands for input output, and then you can configure connections You can, for example, you can configure a connection from each logic block will have a bunch of connections like this, and you can configure it. You can connect, let us say, from the first one. You can make it go like this, like this, like this. You can connect it like this. So in the hardware definition language, you just have to tell from this logic block, this pin connected to that logic block, that pin, and then the system will do it for you. It's amazing. It's extremely complicated. It's not easy to understand how this works. So we will treat it like a black box. We will not figure out how FPGA is built. But it is extremely complex how it's built. We will not worry about it. We will know. We will learn as a user, just like the journey, the big picture. When we use the computer, we know how to operate it and stuff, but we don't know the inner workings. Same way, we will treat FPGA at that level. All right. And the activities that you guys will do will be very, very simple, because this is not an easy thing. Even MTech students will be struggling with FPGA. It's not easy. So we will not bother to learn it now. Learn it as a user. Then over the years, you will become more familiar with it, and then you will be able to do more things with it. All right. But so happy that you children got access to this, and you can play around with it. You are not going to damage it or destroy it. You can play around with it, and later on we will do some activities on FPGA. So the FPGA is important because now, for example, satellite systems. Satellites are far away, going around the Earth. Just imagine if the satellites are built using Arduino type components. If there is some mistake in the program, it's very difficult to fix because the wiring is already there. The wiring is already made. So FPGA is used in satellite systems because if a mistake is detected, after a few months, few years, you can change the wiring itself. You can change the wiring itself. You can reprogram the wiring. That is the difference between Arduino and FPGA. Otherwise, they look the same. They will also have the same USB-C connector. You have to connect it to your computer. There you will use Arduino C or Raspberry Pi C, and you will program. Here you will use HDL. You will use hardware definition language. Commands will look very strange in HDL because now we are describing how the components should be connected, how the gates should be connected. Alright? So that is the introduction to FPGA. If you have any questions, you can ask now, and after that we can end the class. Alright, no questions? Great. So see you next time. I don't know when I'm going to schedule it, but I will let you know. Okay? Great. Good night, guys.
Good night, sir. Bye, sir.
Bye.
Good night.
டக்குன்னு முட்டை
தூக்கமா இருக்கு.
சரி டக்குன்னு போன அவர் இன்னும் ஏதாவது சொல்லியிருந்தாக்கா கீழே உங்கள் அப்பா கூப்பிட்டு அடிச்சோம் நான்
அங்கே
எதை மூடிட்டு எந்த அத்தை
அந்த லிங்க் மூடி